in per. Welcome back, folks. You have done the topping off. Well done. Completed so now we will do the pre-discharge line cooling, because our lines will be empty before the discharge. We are discussing now the discharge operations, and what we will do is technically all the lines need to be cooled from the cargo. So once we have done the line cooling, now we have two ways of discharging the cargo. We discharge the cargo through our liquid header and take the vapor from shore. If the shore is not able to give us the vapor, we will have to give the part of liquid to our vaporizer, and from the vaporizer we will be able to make our own vapor and throw it in the tank. So at this stage, we will be able to maintain, we are more in control. If we need more vapor, we will create more vapor. If we need less vapor, we will create less vapor. So we can manage ourselves more better, and we have only one line. And this is normally what happens during the bunkering on board the ship, that the bunker barge provide us with the liquid, and once bunker vessel is discharging to the ship, and the bunker vessel also creates its own vapor to fill the space which is being created by the vapor. So discharging method depends on the type of ship, cargo specification, terminal storage, bunker vessel capacity. So what we are technically doing is discharging by pressurizing the vapor space. So we have but mind that we can only pressurize type C tank which can sustain certain pressure. We cannot pressurize the tanks which are membrane tanks, because otherwise we will damage the tank. So discharge without booster pumps. Of course, booster pump we normally do not use on the vessel, but if you want to give a pressure to the liquid, we may use. But normally on the LNG carriers we do not have the booster pumps, but booster pump is one of the possibility. And of course on LPG carrier we do use booster pumps. So this is another diagram where we are discharging to the liquid to the shore, and from the shore vapor tank we get the vapor into our tank. This operation is fairly simple, and it is the ideal condition where you connect your vapor line and your liquid line. So technically it is just an exchange of vapor. You are filling the shore tanks, and from the shore tanks you are taking their vapor. So it is a win-win situation for both of us. They do not have to reliquefy vapor to put in their tanks, and of course we have a space. We do not need to use the vaporizer to put it in our tanks, the vapor in our tanks. So normally this is the one which I was talking to you about, the cryogenic pump. This is the pump. You need to understand before the discharging the pump. This is our pump, which has got the pump at the bottom, and pump at the bottom, and we are discharging it to the shore. And in that thing, we will have to see where. Just bear with me for a second. Yeah, this is the pump, the strainer at the bottom, inducer here. The job of the inducer is to give the liquid to the tank itself. Sorry, to the impeller itself. I'm not sure, folks, if you are able to see it properly. I think the outside people are not able to see it. Folks, can you hear me, outsiders? My virtual learners, can somebody give me the feedback that can you hear me? I'm hoping that you can hear me, folks. Um, Sorry, my physical learners in the classroom. So what it is doing, the impeller centrifuge it, and from that centrifuge, what we are doing is it centrifuges the cargo from these fine lines around the tank. Uh, um, in the tank around the pump, and then there is another strainer on the top. Now I think our contact is established with the outside learners, and you are able to see me much better, and I hope you are hearing me as well. Can somebody confirm me that you are hearing me okay? Please just write, because I'm worried that you should not miss this part of the lecture, because your discharging operations depends on the understanding of the pumps, the cryogenic pumps which you are going to use. Can somebody confirm me that you are hearing me? All right, can you hear me? Okay, let's press on. This is where the liquid will go. The partial liquid will also go and do the cooling of bearings. Technically, there are no lubricants or grease here, because no grease will sustain minus 161 degree temperature. It will freeze. So normally we are using the uh, cargo itself as a lubricant as a bearing. So in these two pictures, you are seeing a faulty pump in a cold condition has been taken out, and other pump is being installed in its place. So this is the pump picture. From the bottom, you can see the inducer here. It is feeding the liquid. And can you see on this side there is hardly any clearance in between the casing and the impeller, because the liquid in between is the space is less, so that no liquid will flow back. And of course, if we have the hydration tank at the bottom of the tanks, they are going to damage and the clearance will increase. So this inducer is a very sensitive piece of or part of the so the main flow, you can see, is going like that, induced centrifuge by the impeller, going from the side and going through the discharge. But a secondary flow is also created, and that secondary flow is going and not only cooling down this thing, but also lubricating the bearing, the top bearing and the bottom bearing, and of course the flow also goes out with the main stream of the flow. So this is the motor which runs on a very high voltage, and the voltage goes right down to the pump or to the junction box, and this is the wire cables or cables which connects to the induction coil or the starter coil. So this is another picture of a cryogenic pump, a very huge inducer, a very huge impeller, the rotor, and in between these 2 points there are bearings. Of course, the main pump here is quite big. One thing which you need to remember is that these pumps are not designed to run on empty tanks. So means they need to be submerged in a certain level of liquid so that they can operate. So once the liquid level is somewhere here, then of course they can operate. In addition to that, 2 main cargo pumps, which are huge pumps in the normal LNG carrier. Of course, they are small in the other vessels. We have got also the small pump, which we refer as the spray pump. So it is just 3560 RPM centrifugal pump, 440 volt, 3 phase, 60 Hertz, and of course submersible 35 kilowatt electrical motor is working here. So a pump is configured with the balance drum as a fixed in tank, and what it is used for, it is basically the stripping. So you can see a very small thing. So whatever the cargo is left after the main pump stoppage, then this is the pump which pulls it out. And this is the pump even we use for our discharging ashore. Pumping to create the boil of gas when we are creating boil of gas. This is the junction box where the cables comes and connect to these pumps inside the tank. So technically, these pumps are always submerged in the liquid when the tank is loaded. So a start of ballast is just a start of electric pump and discharge. Why we are showing you here that discharge valve in these pumps, if you keep the discharge valve open and you start the pump is going to trip. So it is better not to start the pump when the pump is when you're starting the pump, the flow will go and the pump will trip. So we need a back pressure. So we need to keep the valve either fully closed or very lightly or crack open. So once the back pressure is developed inside the line or a pump, we can start discharging. So key thing, fill pipelines and pumps, start motor, and then slowly open the discharge valve. This is what I want to see every one of you in the classroom. When you are starting the pump, you need to start it in this fashion. fill the pipelines, start the motor, slowly open the discharge valve. Okay, we have got another method of doing this thing, that whenever we start this pump, we start discharge and we throw it back into the tank. We kind of recirculate for a while till our pump is settled down, the temperatures of the pumps are settled. Because whenever we give a starting current or a starting torque to a pump, the pumps get very hot. And of course, it need to come back to its cryogenic level, which is minus 161 or 162 degree temperature. Once we have got the cargo moving inside it, this one will be fully shut, this one open, this one partially open, so slowly open, say about 12%, fill, throw the liquid here, start the pump. When we have got the liquid flowing normal, amperes on the pump are settled, the pump is not hot anymore, adjust the motor load slowly and start slowly opening the tank branch valve or isolating valve, and the cargo will start flowing outside. Okay, we have already done the line cooling, so technically we can easily start the operation as soon as the cargo. And of course we started slow, let the shore receive the cargo. Once the shore confirm us that they are receiving the cargo, we can slowly and gradually top up all the pumps. Normally we'll start discharging with one tank and slowly following the same procedure, one pump by another, one pump and another. Then we will go through this process and we will start all the main cargo pumps and discharge to our full capacity. Of course, when we come down to the lower level, we slowly we stagger the tanks, of course, in the height, and we slowly stop the pumps. When the cargo level nearly here, the main cargo pump will stop. So what we will have to do, we'll have to start the small pump or the stripping pump. And of course, we never normally discharge 100% of the cargo. We retain some of the cargo in the tank for as an heat. The bunker barge will also retain the cargo, certain amount of cargo, to keep its tanks cool, because all the heat ingress from outside, from the insulation, etc., will just let certain molecules of the liquid evaporate, and again the tank heat is in those molecules which are evaporated. Now, once we are completing the discharge, we are stripping down. What we will do, we will drain all the lines and tanks, and we have a big responsibility of now maintaining the temperature of the tank, because now we have discharged almost all the cargo. So pump discharge valve should not be throttled for flow control. So this is the very, very important thing, that you should never start the throttle the pump discharge valve. And cargo must be drained from all deck lines and cargo hoses and arms by compressor, ship to ship, or by blowing the liquid into ship tanks, etc. And of course, the main thing you need to know is that we retain certain cargo inside the tank. And of course, once we finish the discharging and when we finish the stripping, what we will do is we will drain the lines and we will purge the lines with the nitrogen. So at the end of the day, we bring the lines to the ambient temperature, and we will also fill the lines with nitrogen. So there is no hydrocarbon gas in these lines, and for that. Now we will do the exercise about the cargo discharge and discharging completion, and later we will talk about the preparing the vessel in a reverse cycle, which is taking the ship to the dry dock. So we will give me just a couple of minutes, and I'm starting the, another exercise. No. Maybe can we give a break to our virtual learners? 2 minutes. Just stop because now we'll do